Good afternoon, everyone. Today we're going to continue discussing machine learning. However, the focus will now be using machine learning for regression. So I requested you to load quant mode and then download Apple data from 2015-01-01 to 2024-12-31. Okay, so let me just close some of the tabs here. Okay, so this is our Apple data set from January 2 up to 2015 up to 12/30/2024. All in all, 2515 observations. And you know very well that this is an XTS object. You have open, high, low, close, volume, and adjusted. Now, when you're doing machine learning regression, and when you're using, let's say, stock price like this, it will be best to use a data frame instead of an XTS object because we might have difficulty with the XTS object. So we're going to convert this class into a data frame. Okay, as you know, class, this XTS object consists of the index, which are the dates, and then this is the core data, open, high, low, close. Okay, so we can now generate a data frame class. Let's call it stock data. Okay, and then stock data, and then data.frame. We introduce a column, date is equal to the index of Apple. So we know that the index of Apple is this one. By now, we know that the XS object has a different index. It contains the date of the asset. Okay, and then the others, the open, high, low, close, volume adjusted, it's your core data. Okay, so if we use the core data function, okay, of Apple, then we will be able to get open, high, low, close. So in effect, class, this one is creating an object called stock data where you have columns, a date column, which is the index of Apple, and then the core data of Apple. The core data, as I mentioned, is open, high, low, close, volume adjusted. Okay, I'll give you a few seconds, class, to run this data, and you should be able to generate a this object stock data, and let's compare, class. I'll give you a few seconds, please. You may run this now. Once you're done, class, kindly please chat in the chat box. Okay, thank you, Aidan. That was fast. Thank you. So let's wait for the others. Okay, good. Moises, Kayan, Kaylee, Paula. Okay, good. Jello, thank you. All right, I hope the others are able to follow. If you have any questions, please feel free to ask. So you're 25 here. That's good. Okay, thank you so much. Okay, let's continue, class. If you have any problems, you know the drill, class. Please feel free to raise your hand, and I'll entertain your questions. I hope the others are able to follow. Okay, so if you run this class, let me view stock data. I ran this already, so okay, anyway, I'll just run it again. And then view. My stock data is C class. You have this column, and it's no longer it's a data frame class. So the index are not dates. The dates are here, and then this is your core data. Open, high, low, close, coming from your Apple XTS object. Okay, so, and then when we check the structure class, it's now a data frame. Okay, it's no longer an XTS object. Now, again, why are we creating a data frame class? Because in machine learning, it would be better to use a data frame. Okay. All right. So sometimes you might need to save the data class. So you now have this stock data. You can create a CSV file out of that. So you can use the write.csv. Okay, write.csv. And then what's the name of the object that you're going to use in writing your CSV? Stock underscore data. This is our data. And then you have to write the file name. Okay, file name that you're going to name the name that you're going to use for your file. So here I'm using Apple stock data 2015 to 24.csv. So this is important. If it's Excel, write .xlsx. Okay, .xlsx. And then row names is equal to false because there are no row names class. Okay, here stock data class. Here stock data. It has no row name class. Okay, then if you run this class, you should be seeing in your environment, in your project class, in the file, you should be seeing this data, Apple stock data. Okay, so this is important because you might want to share this data with others, depending on your requirement. Okay, so if you have done that class, if you have created your object, if you have created your file in your, which will be saved automatically in your R project, then please chat, please confirm class so that I may continue now after you're done with it. Notice I'm not giving you the codes only for some of the codes because I want you to once again write coding because you were coming from a long break, to help you get into the groove because you'll have your quiz class. If the PASCO is on Friday, then we'll have the quiz on Tuesday, face to face. Okay, good. Thank you. All right. So now take note, class, in time series forecasting, there is a natural relationship between the data today and the data at lag 1. Lag 1 means the data, depending on the type of data that you have. If it's daily data, the data yesterday. If it's yearly data, could be, if it's weekly data, the data last week. So in time series, lag features are important because there may be, most probably there will be temporal dependencies. When you say temporal dependencies, it means that values, prior values could affect, okay, the values of today could be dependent on the prior values. So depending on, could be lag 1, let's say daily data, the data today could be dependent on the value yesterday, or it could be dependent on the value 2 days ago, or 3 days ago, or 4 days ago, etc. So it would depend on the lag. Okay, so in this in this machine learning models that we're going to use, that we're going to learn, we're going to use uh, time series data. Okay, and then we're going to use the prior values, the lag values. Okay, that's why we're using time series for our machine learning, because we can use the lag, the prior values class. And then we're also going to use other metrics like moving averages, or relative strength index, or moving average convergence divergence, uh, exponential moving averages, etc. Okay, we're going to do regression class. We're going to regress the log returns of an asset. Here we're using Apple on some indicators, some technical indicators, and some lag values. Okay. So let's first create class. Let's introduce a variable class to our stock data. And let's preserve stock data class. So I'm creating this object called stock data1 so that we can preserve our stock data. And here, class, what am I doing here? Okay, stock data1 $apple.close.log1, which means that I'm going to introduce, Okay, in this object called stock data, which is the same as stock data one, which is the same as stock data, I'm going to introduce now a variable apple.close.log1. And what's inside this apple.close.log1? Okay, you can see it's NA and then head of stock data one apple close and then -1. So let me explain this. Let me go to apple class. Okay. Of course, we could have just created the apple close, an object with apple close, and then remove the open high low close. Okay, that could have been uh, let's say better, more manageable, but I decided just to maintain this object. Okay, I now want to create a variable called apple close log1. Apple close log1 class means that the value, let's say the value on this date here, the value on this date is equal to the value of the previous date if we're looking at apple close. Okay, so the value here will be 27.3325. So we're taking a look at the previous value class, previous daily value. What will then the value here be? The value here will be NA class. Why NA? Because we don't have any prior value. So for the first date, January 2, 2015, since we don't have a prior value, this will be NA. The value here, January 6, will then be the value of the previous date, 26.5625. 26.5625. Okay? So I hope you understand that. Log1 means you're creating now an object, not an object, a variable where its values will be equal to the prior value, depending on what log you're using. If you're using log1, it will be 1 day before, because these are daily data. Okay, now what will happen to the last one class? If I go down here to our last value, here class here. So for December 30, the value should be this one, 2559. So this one goes here, class. 2559. It will go to the last row here. Okay? What will happen to 252.2? Then it will be deleted, class, because you're not looking at a row beyond December 30. Okay, up to December 30 lang yung data natin, class, no? It's only up to December 30. So we're not looking at this row of observation. Okay, we're not looking at, maybe that's January 2, 2025. We're not looking at that. So 252.20 will not go here, class. So what really happens, class? What happens is that all our data here, all our data, class, 273325 will be here. Okay, so from here down to the latest observation, down to the second to the latest observation, 255.59 will be included in the log1, except for 252.20. So this will not be included in our log1 class. What will be included is the earliest one, okay, 273325, it will go here, up to the second to the latest one, class. And then what will now happen is that you'll have an NA here. Okay. Now, if it's log2, class, then you just look at two prior values. Okay. So this one will be also NA. You don't have any two prior values here. This one will also be NA, class. Why? Why, class? For this one class, lag2, so you start here, go previous, and then another previous one class. But since there's no value here class in the two previous class, then this one will also be an NA. How about this one class for this particular row? Okay, for lag2, it will be 1, 2. So this will be 27.3325. Okay, so that's your lag2 class, lag2. So in a similar fashion, if we go down class, if we go down here at the last row class, the value here will be again 1, 2. So this will be 259.02. Okay, what will happen now to 255.59 and 252.2? It will be removed. So there will be no value here for lag2, no 255.59 and no 255.2. Okay, so it's all your aapl close, all of your aapl close, except for the latest two. Okay, so that's for lag2. So how do we now create this? Okay, so manually class, okay, this I illustrated to you. Stock data 1, so this is exactly the same as stock data. And then we're going to insert this variable. Apple.close.lag1. And it will include NA. That will be the first, the last observation there, right? And then the head of stock data 1 Apple close, and then -1. What does this mean, class? Include everything except the latest one, -1 class. Okay, which I illustrated a while ago. It will exclude the latest class. Same thing class here, stock data 1, and then introduce apple.close.lag2. It will be combining NA and another NA. Okay, and then head stock data 1 apple.close, then -2. So it will exclude the latest two values. It will include everything class from the earliest down to the last, except for the last two. So that will now create your lag2. Okay, I'll give you a few seconds class to run this, and let's check what's your stock data 1. So you'll have two additional variables there, apple.close.lag1, apple.close.lag2, and you will see that there are NAs there. Okay, can you please check class if you're getting the correct. Okay, let me run this. And you should be having this result class. There. Apple.close.lag1, no NA. Apple.close.lag2, no NA also. And then if you check below, so the last observation here is 255.59, which is the previous, the lag one, 255.59. The last one here is 259.02, which is the two, the lag 2 plus 259.02. So this one. Okay. All right. Kindly confirm class if you were able to get the result. Stock data 1. Okay, let me show again the code. Okay, good. Thank you. So more feedback from the others. Good. Okay. Let's give your classmates a few more seconds. In case you have questions, class, please feel free to raise them now. Okay, a few more seconds, please. I hope others will respond. Okay. All right. Thank you. Thank you, class. Okay. So let's continue. Now, we did this manually, di ba? Nag-create tayo ng we created an object where we introduced NA for log 1, 1 NA, for log 2, 2 NAs. You can actually use tidyverse class. So let's discuss this. Okay. Tidyverse, as you know, is a family of packages, and one of them is dplyr. Dplyr is good for data. Uh, what's the term for that? There's a term for that where we mhm, data crunching. That's not crunching. Okay, I'm sorry. I forgot the term where you modify your data. You create new rows. You create new columns. Anyway, okay. So what are we doing here? I'm going to preserve stock data one. So we're going to create another object, stock data two, and then you have here stock data using the original data. If you recall, class, this is your pipe operator. Okay, slash greater than, and the shortcut is Control Shift M. Okay, and it means and then. Okay, and you know the old name is the pipe operator. Old name is percent greater than percent. So this is your pipe operator. Okay, very convenient. Okay, so what do we do here? We have we're creating this object called stock data 2. So we're starting with the original stock data, and then we're going to mutate. To mutate means to create new columns. So what column, what variable are we going to introduce? Number one, aapl.close.log1. Okay, so take note we're using the stock data object. If you recall, stock data is this one, class. That's your stock data, right? We're going to introduce, we're going to mutate this data, introduce aapl.close.log1 and aapl.close.log2. And it's very easy, class, because the function is just log. So this is a lot easier than having to, and this becomes more let's say convenient or efficient, especially if you have, let's say, higher logs, log 5, log 6. Imagine if you have log log 5, then you'll have to introduce here 5 NAs. Okay, with this one, just identify n. N is equal to 1 for log 1, n is equal to 2 for log 2. Okay, I'll give you a few seconds to run this and check, plus, if you're getting the same object as stock data 1. So this is the better approach. This is the more efficient approach using the mutate function. And of course, the pipe operator. And the log function, log. Just identify the log n is equal to 1 or n is equal to 2. So if you're done, class, and you have compare them and saw that they're the same, okay, kindly chat, please, in the chat box. Dplyr, by the way, class, is in tidyverse. If you load tidyverse, then you'll have a family of packages including ggplot2, per, okay, lubridate, dplyr, tidr, so many packages that come with it. If you're done, class, kindly chat. Okay, thank you. All right, good. So I hope you got the same result as stock data one. Stock data one and stock data two are just the same. Okay, for stock data one, we did it manually. For stock data two, we used the mutate function, which is very convenient because you can, if you want to create, for example, a log, 5 period log, then you just use log apple.close and then n is equal to 5. And then you'll have 5 NAs. Okay, a few more seconds, class, and then I'll continue. Okay, good. Okay, no questions. All right. Now, there are others, class, that we're not going to look at them. There are other ways to do this. For example, you can make use of the zoo object. Pareho lang siya, class, no? Just the same. What will differ is that k is equal to 1, k is equal to 2. So here, for the mutate, it will be n is equal to 1. This is also convenient, class, because we don't have to use the mutate function. Okay, I'll leave you, class, to discover this for yourselves. Okay, and then there's another one, the embed. I'll not discuss this. So let's go here now, class, because this is the more important uh, discussion now. So I'm not sure if we used TTR before, technical trading rules. So let's first go to packages. And since we already loaded quant mode, definitely TTR will be loaded also, technical trading rules, because TTR comes pre-packaged with quant mode. So let's just take a look at this. Okay, so what's the technical trading rules package for? What's this for? So let's take a look at the, so go to packages class, and then type TTR, and then click it. Okay, click this one, and you can check. So this is technical trading rules version 0.24.4. It also imports the function, the package XTS, zoo, and then curl. And it links to the XTS package and also enhances the quant mode package. Okay, so what does it do? It covers, it's a collection of over 50 technical indicators for creating technical trading rules. So this is really very convenient for technicians. Technicians are those that use technical indicators in order to to craft their strategy as far as trading is concerned. Okay, so it was the creator and author is Ulrich. Okay, another contributor is Ethan Smith, but this is maintained by Ulrich. By the way, Ulrich has also many other packages that it contributed to the archive CRAN. Okay, let's go back here. And there are many functions here, class. Okay, B bands, I think I mentioned this to you before, which is Bollinger Band, CCI, Commodity Channel Index, okay, EMA, moving average, okay, EMA, exponential moving average, okay, what others? Many, class, no? More than 50, we're going to use some of them, moving average, convergence, divergence, momentum, okay, what else? Rate of change. So more than 50 technical indicators. We're going to use some of them, like RSI, Relative Strength Index, okay, MACD, the one that I showed you a while ago, okay, and some other uh, momentum indicators, etc. We're going to take a look at them, and we're going to use them in order to predict the returns of Apple. Okay, so let's start with the first one, the very easy class, moving averages. Moving averages, class, are rolling averages. So let's start first with including now another uh, variable called MA underscore 20. Okay, so we're using, from the technical trading rules, we're using SMA. SMA stands for simple moving average. And what average are we doing? Are we performing? We're using the stock data one, okay? Stock data one object, in particular the Apple closing price, and then we're getting the N is equal to 20. So we're doing the 20-day moving average. Okay, so let's run this first and see, class. Control Enter and see what happened to our stock data one. Okay, here. Stock data one. Notice now there's a new variable here, MA20. Okay. And there are 19 MAs here, NAs. And the 20th is this one. So let's just discuss what is this MA20 all about. And this one also, 27.77, 27.93. So this is actually a rolling rolling average. Okay, so let me explain this further. Okay, so that's MA20. This is moving average 20. So it's a simple moving average because there are other types of averages like exponential moving average. For exponential moving average, so for simple moving average, 20 days, it gets the average of the 20 days, class. How do you get the average? You add all the 20 observations and then divide by 20. Okay, so it's just like getting 1 over 20 of each observation, diba? And 1 over 20 is 5%. So you're just getting 5% of each of the observation, adding everything to generate 100%. That's your simple moving average, equally weighted. Okay, so let's just check, class, kasi yung unang ano natin sa stock data, the first one is 27.66. So maybe let's just, okay, let's create an object class, Apple aapl underscore close, okay, underscore 20, okay, alt minus, okay, and then let's get from our stock data na lang, no? Stock data, okay, we're going to get Apple close, okay, Apple close, and then just, okay, just What row class? How many rows? Because we already identified this one, the close. And then how many rows would we want to get? Let's just get the first 20 rows class. Okay, first 20 rows, control enter. Okay, and we now have this aapl close 20. This will contain the first 20 observations. Aapl close 20. Okay, let's check class. There. Aapl close, how many observations? Okay. 20. Wait. Sorry, I made the wrong code because I'm now referring to 20 rows. Wait. This is our 2515. Wait. Okay. Let me. I just want to get the first 20 observations. So stock data. Okay. Maybe I'll change this. What row? Row is 1 up to 20. First 20 observations, and then, okay, here. Yeah, we can use this. All right. So I just want the first 20 observations, class. 1 up to 20. Sorry for the wrong code a while ago. Okay. So what are we doing? I'm creating this object, aapl close 20, and then stock data, the aapl close, and then just the first 20 observations. Let's run this. And then now you can see that I think aapl close 20. Where's my aapl close 20? Sorry. Yeah, I used the wrong object a while ago, Control C. In the other section, we created this aapl close. Here, let's just create aapl close 20. I just want to illustrate, class, how we get the moving average. Okay, Control Enter. All right, there. Oops, what happened? So aapl close 20 is just a, okay. So 20 observations, class, no? There. 1 up to 20. These are the prices of aapl close, okay, of our stock data, which is the same as aapl close. Okay, we did not create aapl close class, no? We created aapl close 20. Okay, so we can get now the mean, mean of aapl aapl close 20. What's the average, class, of the first 20 observations? Control Enter. You get 27.66. So how does that compare with our stock data MA20? Okay. 27, here class, 27.66038. Okay, so I just verified, class, that that MA20 will get 20 observations and get the average of that. And you notice how, if you count this, class, 1 up to, this is the 20th. This is the 20th, which means, class, that when you do MA, moving average, let's say MA20, what what TTR will do is that it will get the 20 observations, get the average, and then replace the last observation with the average, this one. So the last observation was 9.29. This is the 20th observation. And then it replaced it with the average 27.66 of the 20 observations. Then it will roll. It will roll. This will be now data number 2 up to 21. Okay, so if you get the data from the second observation here up to the 21st, which is also 20 observations, and then you get the average, you get this one, 27.77663. It will replace this one. It will replace 29.6575. Okay, so let me request your feedback, class, if you got the concept behind MA20. Moving average, class. It's a simple moving average because we're just getting the equally weighted average, which means all the observations divided by the number of observations. Okay, we add up all their values divided by the number of observations. So we're just getting practically just getting 5% each of your observation. Okay, is that clear, class? How about the others? A few more seconds for the others to reply if they got the meaning of that SMA 20. Okay. All right. Thank you. So let's practice, class. What if it was MA5? Just to illustrate, class. We're not going to use MA5 here. So I'm doing here. Let me just close this. Here, class. Let's create now, introduce MA5. So it will still be SMA. The only difference is that this is now N is equal to 5. Okay, so it will get the first 5 observations, get the average, and replace the 5th observation with the average of the 5 observations. Then go from data number 2 to data number 6. Again, get their average, replace the 6th observation with the average of data 2 to 6. So if you run this, class, run, control, enter, and then view the stock data 1, we now have this one. At the end, we now have MA5. So 1, 2, 3, 4, the 5th observation will now be the average of the first 5 observations, etc. Okay, once again, class, your feedback. That was the same lang siya, no? Nagbago lang ng N is equal to 5 observations, yung moving average natin. Okay, did you get it, class? Okay, good. So simple moving average, class, very self-explanatory, very easy to understand. Okay. All right. Let's now go to another type of moving average, and it's your exponential moving average. Okay, I'll share with you just this notes, class. But the code, I want you to do it. Control C. Okay, so you can put that note. Exponential moving average. Now, this is not the same as your simple moving average. Kasi it's a weighted moving average where more importance is given to the recent prices. Okay, so it's practical, and it's on solid ground. That most likely, class, the prices yesterday affect the prices today more than the prices 40 days ago. Okay, that sounds very logical, class. The prices today are more affected than the most recent previous prices. Price yesterday, the price 2 days ago, maybe the price 3 days ago, rather than the prices 100 days ago, class. So that's what happens with the exponential moving average. Okay, so we will not look at how really this is computed. There's a formula for that. Okay, so we can do EMA 12 and EMA 50, class. Okay, EMA 12, and it will be interesting to see to plot this. All right, but let's go first to EMA 12 and EMA 50. Let's run this. So same thing from the TTR package, EMA. Stock data 1 apple.close. We're basing it on apple.close, or of course you can base it on stock what's that? Stock data, because stock data is the same as apple.close. And then this is n is equal to 12, exponential moving average, and then n is equal to 50. Okay, so let's run this. So this will now add two more variables to our stock data one. Okay. If you're done, class, kindly once again comment. Okay, good. Thank you. All right. So the only difference here, class, is ito, no? N pareho lang, same. SMA, EMA. So exactly the same. Okay, and if I now view my stock data, okay, this is now my EMA. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Same thing, class, the 12th. But the difference, class, is that it will not be divided by 12. The sum of this observation divided by 12. It's a weighted moving average. It will give more weight to the most recent ones. And there's a formula for that. We're not going to take a look at that, class. And then this one, EMA 50. So you're getting the average of the 50 observations, class. Okay, 50 observations here. Okay, MA 50, and then MA EMA 12 and EMA 50. Okay. All right, let's move on, class. Okay, so now let's create another metric, relative strength index. Okay, I'll leave you, class, to try to find out what does RSI measure. Okay, you can find many information about that, class, and the usual is 14-day relative strength index, class. You can check the definition of this. I'm trying to accelerate so that we have the same discussion as the other section. Okay, I'll leave you, class, to do a little reading. Just Google nyo lang, class, so just Google it. What does RSI measure? Why is it oftentimes used as a technical indicator? So same thing, class, we will use the RSI function, okay, and then append it to our stock data one by creating another column, RSI 14, okay, and then 14-day, class, 14-day relative strength index. Let's run this. And then you have now another stock data one. Okay, here. And if you take a look, class, at RSI 14, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, unlike, class, the MA, where let's say MA 20, where you replace the 20th observation, here, Okay, you replace the +1 observation. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and then 15th class. So the measure is different. Okay, there's a formula, 100 plus 100 times over 1 plus RS, the relative strength index. So just take a look at class, how the RSI, the importance of RSI and how it is computed. Very basic formula lang yung class, 100 plus 100 over 1 plus RS. Okay, so I'll not go into that detail. I'll leave that to you, class. Okay, so what do we have now? We have now a data, stock data 1 class, which have many NAs. And you very well know, class, that that we cannot uh, work on this, no? We cannot work on a data that has several NAs. Okay, so what do we do now? We remove the NAs, class. We remove the NAs. How do we remove the NAs? That's very easy. We have already done that in the past. So stock data 1, NA dot omit, stock data 1. So what will happen is that R will remove all the NAs here. So what will prevail is the data here, the data that has the most number of NAs. So this will be, everything will be deleted, class, for all observations. So this will now be the start, no? This is so March 16. That will be the start because of our EMA 50. This is our EMA 50. So this is the 50th observation. All the NAs will be removed. Okay, so let's do that, class. Okay, so stock data 1, NA dot omit stock data 1. So all the rows with NAs will be removed. And then kindly check, class, run this, and then view your stock data, and then also sum all the NAs, class, from your stock data. Let's see if there are NAs. So I want you to run this and tell me, class, if what happened to your stock data 1, and what's the sum of your NA for stock. Sorry, this is stock data 1. Okay, it should be stock data 1, class. Sorry. I'll wait for your feedback, class. What happened to your stock data 1? Do you still see the NAs? And what's the sum of the NA for stock data 1? Okay, thank you. Aidan, thank you. No more NAs, sum is 0. Okay, very good. Yeah, Moises, thank you. Yeah. So sum is 0. Migs and Paula, thank you. So for the others, please. Okay, Adrian, thank you. Okay, good, Kylie. All right. So I hope the others are able to follow, class. Okay. So now that we have a, let's say, a stock data, I haven't run that. I'll run this one, class. Stock data that has no more NAs here. No NAs. Good. I have now 2466 observations from the earlier 2515. So we have deleted some observations, in particular those that have NAs because of the technical indicators that we included in our data. Okay. All right. Now, what we're going to do is before we do our regression, class, we will have to, because of overfitting, we will be splitting our data. Now, last time, what we did was to use either the sample and the create data partition. So we said for our data, it was a cross-sectional data, di ba? Wala naman time series yun. Walang time yung data na yun. We used the either the sample function or the create data partition. And we said that the create data partition was more powerful, okay, because it was able to preserve the proportionality of our dependent variable, which was a categorical variable. In this case class, okay, what we're going to use is the sample function. And I'll explain the reason for that class. Because here, for our time series data class, this is time series, right? Time series siya. Okay, we have, okay, wait. Let me open again stock data one. Okay, the question is how are we going to split this data into a trained data and to a testing data? Unlike the one that we did before, class. Okay, wait. I have to show the date here. The one that we did before, class, if you recall, it would choose, okay, numbers like okay, 50, 51, 52, and then 56, 57, 60. It would draw out samples. Okay. Some would be chosen, some would not be chosen. Those that are not chosen, for example, would go to our testing data. For example, this one. Let's say these were the ones that were not chosen. This will now go to our uh, testing data. The others will go to our training data. That's what happened when we use the sample function. Now for time series, this cannot be class. This cannot be. We cannot just draw out an observation here and put it in the testing data set. Okay, those that remain will be placed in your training data set. That cannot be. Why? Because this is time series class. We cannot change the order, the logical order of your data. So what's the best thing to do here? The best thing to do here, class, is to determine, for example, how many percent will be for your train, let's say 80%, how many percent for your testing, it will be 20%. So define the 80th percent up to this one, for example, up to this one. So this will now go to your training data set, and the others from this one up to the last data will be your testing data set. Okay, so you can now see the difference between generating your training data set and your testing data set for a time series data. We cannot change the order of the data. So we have to start from the first observation up to a certain point where we want, which we want to be part of the training, and then from there add one up to the end. Okay, so how do we do that? Let me illustrate that. It's almost time, class. So let me just finish up to this one. Okay. Okay, so I'll, for purposes of to make it the same as the other section. Okay, let me, right here. Control C, Control V. I'll just paste this class. Oops. I'll remove some. Okay. Control X. Okay, so let's run this class. So how do we split our data? So set that seed so that we'll have reproducibility. Actually, this one might not be necessary, but let's just put that. Why? Because we're identifying class the floor. The floor is 80% of your number of observations of your stock data. We know that our stock data has 2466 observations. So the floor means, okay, from the first one up to 80% of your n row. So let's run this class. Train size train size is 1972, which is 80% of the number of observations of our stock data, which is, what's our stock data one? 2466 times 80%. So 80%, 0.8 times 2466. 2466 ba? Okay, 1972. Okay, 1972. So here it's 1972, okay? 1972. So that means, class, when we now split our data, it will be from observation number 1, the first one, up to 1972, and then from 1973 up to 2466, it will be now your training testing data set. Okay, so that's the logic behind. We will have to preserve the order of your time series. So how do you do that now, class? Train data. So stock data 1, it will be from observation number 1 up to the train size, class, and include all the columns. Train size is 1972, right? So that will be from row 1 up to 192. And then your test data now will be same. From the stock data 1, you use your train size. Train size is 1972 plus 1. So that means it will be from row 1973 up to the n row of your stock data. N row is 2466. And then, so those are the rows, then include all the columns here. Okay, so that's how we generate now our training data and testing data for this time series. And if we check, class, if we check this, how many is our training data set? Yung N natin, okay, how many? 1972, okay? And then what's our testing data set? 494. If you add this, class, it's 2466. And then let's check, class, okay? If you, I'll just ask you to run that. I'll just run this, class, ito. Let's get the first and last few dates for better visualization. So first and last dates. So for our trained data set, the first 5 dates, so head, our trained data for the date, first 5 observations, and then the last 5 dates, tail naman, no? Tail, last 5 dates. And then also for our test data set, let's get the first 5 observations and the last 5 observations. So let's run this, class. Okay. So take a look, class. Training data set, first 5 dates, 2015, 316, which is our stock data, yan, 316. No? So first 5 observations, 316, 317, 318, 319, 320. And then last 5, 16, 19, weekend to, no? 17, 18, 110, 111. Kasi ang stock data natin hanggang okay. So that's our train, no? Hanggang 111, no? 111 yung sa training natin. When we go to the test now, class, you notice, yung simula niya, nag-end dito ng 111. For the test data set, it now begins with 112. Okay, so you can see here that the temporal, that the arrangement of your data for train and test as a time series were preserved. Okay, and then our last 5 dates will be 1223 until 1230. Okay, so we now have a training and a testing data set. So this is very important, class, when you do your paper and then you're splitting your data into training and testing. Make sure that you don't use the create data partition. The create data partition will have a role later when we do our modeling. Okay, but not for this one in splitting your data. Okay, so okay, I'm happy that we were able to. I'll end now the recording.